Luis, thank you so much for joining me today.
Thank you for having me on the show. Thank you.
Let's start with the big announcement of last month. You announced OctoAI, an AI
Mhm.
compute service to run, tune, and scale your generative AI models. And you also said that it's a self optimizing compute service. So,
Right.
can you explain what this is about? And also, what was the motivation behind launching this?
Yeah, absolutely. So, I mean, the quick history is that, OctoML has a history in building efficient machine learning systems, right? So, this is the OctoAI compute service is an evolution of our platform of turning machine learning models into highly efficient things that, artifacts that can run on a bunch of different hardware. And based on everything that we've learned, in iterating through our product, it became clear to us that what users want is an easy way to get access to efficient compute, especially in the era of generative AI, right? So, and given our expertise in again turning machine learning models into highly efficient executables for different hardware, we use that know-how and those engines that we built to build this compute service that's self-optimizing because we take models and automatically accelerate them, automatically select which hardware they should run on based on performance requirements, based on cost, and based on availability. Right, so
Right.
that means that you really get the benefit of abstracting away all of the complexity of the hardware and software infrastructure involved in running AI models.
Perfect. And OctoML has been a pioneer in this space where how do you make AI models faster, more efficient when you run them? So, all right, let's say I am an AI developer and I want to make LLMs faster and cheaper. And let's for a second assume that this was before something like OctoML was available. So, what are all the different ways in which I can achieve this? This meaning making LLMs faster and cheaper.
Yeah. By the way, this has been a good chunk of my professional life. And as a very quick abridged history of my life here, came to the US 20 something years ago from Brazil to work at IBM Research in the Blue Gene machine. We're building hardware and software for protein folding at that time. So which might come back later, in some of the topics that we might talk about here. And that means that building high performance hardware software artifacts has been something that I've always been passionate about. And we started working on the problem of making machine learning AI workloads more efficient for, I don't know, like probably 15 years ago when I joined the faculty at the University of Washington, starting with approximate computing, which is the idea of approximating the computation involved and the storage involved to reduce energy requirements, for example, to building compilers that can automatically reduce the computational intensity of applications by quantizing values, by changing, rewriting parts of the algorithm, and so on. So, anyways, I'm just saying that this is coming from not just hey, this is what we tried and worked, but from like a long line of there was several PhD theses involved in a lot of these learnings, not only in my research group, but from many other research groups in building, I'd say, computer systems in general, especially machine learning systems. So, and one thing that I just want to bring up that I thought I should have brought up in the previous question was that I don't think people really stop to think about how much compute is involved in some of these modern use cases of generative AI. Like if I were to ask you, how many computer operations do you think is involved in one text to image stable diffusion run?
Mhm.
Do you think it's billions, tens of billions, hundreds of billions? It's actually in the trillions to tens of trillions of computer operations to produce one image. I mean,
Right.
just this is an incredible amount of computation, right? So,
Yeah.
and then even some of these small, LLMs that we're seeing that has say 10 billion parameters, you're still talking about tens of billions of compute ops per token of output. So when you multiply that by the size of the output, which is normally in the order of thousands of tokens at the minimum, you're really talking about trillions of compute operations, even for very casual use of LLM. So this just to put in perspective that these are some magnitudes of compute involved that we have not seen in any meaningful, in any, let's say, everyday compute applications. This was really the domain of high performance computing when you're doing large scale climate simulations or chemistry simulations or molecular dynamics. That was in the domains of those. But now this we're doing like in everyday applications. So I wanted people to really think about this and be grateful to all these advances of many many humans that devoted a lot of their lives to making computers fast.
Yeah, yeah.
Anyways, so now answering your questions, what is involved in making LLMs run faster and cheaper? It's a few things. I mean, the first thing is producing highly efficient code, right? So in the end, when you are running an LLM at the very lowest layer, what it becomes is a series of linear algebra operations. There's a lot of matrix multiplications, matrix vector operations, and in some cases some operators involve convolutions and so on, some more specialized operators, right? So turning the machine learning model into highly efficient executable that makes the best use possible of the compute engines and of the memory that you have available and all the memory hierarchy. For those of you who had the computer science background, like optimizing things to use like caches and fast memories and so on, like making maximum. This is historically has been really done by hand. You have what I call artisan code, people that really go low level and understand what the algorithm needs on the hard needs and writes really low level code that tunes for that. So we've been working for a long time. In fact, leading up to OctoML, when building Apache TVM, we built, we were some of the pioneers on using machine learning to generate efficient machine learning code, right? So using machine learning itself to search the right way to generate the code. Okay, back to your question. So making it fast and cheaper boils down to generating the most efficient code possible such that you make the maximum utilization of compute and memory bandwidth and also memory capacity. And then the other thing is making that portable, giving you the ability to run on different types of hardware, like different GPU models, maybe even on CPUs or accelerators, gives you another dimension of picking the cost, the price performance trade-offs, right? So making the code run faster is good for everyone. Like any hardware back can
Right,
benefit from that. But
right.
then once you compose that with portability, so now we have a second axis to optimize for, because as you all know, so there's a market for computing in public clouds. You picking the right compute at a given time might give you cost advantages. So but then the other thing that I think is important more on the system side is not just about making the code run fast, but also building the rest of the system. Like how do you batch requests, in an efficient way such that you get higher compute utilization without compromising the experience on the other end, without people having to wait for too long for the output to come back. Also multiplexing, how do you do very fast context switch of different types of work and so on. And finally, how do you do all the systems work of spinning up instances very quickly, spinning them down and making, very careful orchestration of all of the compute nodes involved in offering the service, right? So I know there was too much in the weeds, but I can't resist. You woke up the
Yeah,
computer
yeah.
systems researcher in me here. So was that
That's
was that reasonable, particularly? Okay, all
That's
right,
perfect. Yeah, yeah. I think
okay,
that's pretty much exactly where I was going with this. Is even before we talk about the premise of
hmm
OctoML, I just wanted to know, hey, if a researcher were to try, like, where do they even look? Like, what are all the possible ways in which we
yeah.
can get efficiency out? And that's perfect. All right. Now
Yeah, and
coming
can I
to
add one quick thing that
yeah,
it's, you touched on a big motivation too, even for how we're thinking about our products going forward. I mean, historically we had focused on machine learning engineers as the persona, but now is the time really to target general application developers as the personas. If you can really abstract away the complexity of how to make these models run fast and efficient. Like today, when you go to OctoAI, we have templates, for example, text to images ready to go that you can really call with a couple lines of code, right? So that's the kind of level of abstraction that we are striving to offer to users, so people can very easily build applications. So
all right. And historically, or at least what OctoML is more famous for, is on the inference side, meaning,
mhm,
hey, the models you run on the OctoML platform and it'll be fast, it'll be efficient. So you need a lot of compute for
mhm,
the inference related work. And
right.
also, there's a whole chunk of compute that people need for training, for example,
Training.
right? So for a layman, how would you explain or maybe compare and contrast the compute requirements of training related work versus inference related work? And
Yeah.
also just yeah.
No, it's great. No, it's a great question. So now, you train once, and for any model that you've trained that has actually good value, has utility, people are going to use it a lot. So for any successful model or any model that people actually want to use, very very quickly the amount of compute and the amount of the cost involved in running the model gets dominated by inference. Okay, so that doesn't mean that there's no. I'm not saying that there's no business in training. That's not what I mean. A lot of people actually train. Just being in the business of training models and evaluating them and finding the ones that work for you leads to meaningful amount of compute, and there's a meaningful, definitely meaningful business there. And as demonstrated by several companies like Mosaic ML and so on. There's really a legitimate business there. But we have to pick our focus, and our focus has been on inference from the beginning because I we've been betting on this future that it'll be machine learning models going to be deployed widely. And then if you zoom out and look at the lifetime of a model, the majority of the compute cost and compute time would go to inference. Okay, so and this is turning out to be the case now. But that said, now I want to contrast the moment we're living right now with foundation models and the ability to fine tune existing models to customize the models. And now there's a little bit of a blurring the lines between what's training and what's inference, right? So in many cases, you might have a foundational model, you do a little bit of fine tuning, and then you go and do some inferences on that fine tuned model. Stable diffusion is one example. You get a stable diffusion based model, you fine tune it for some images for style and so on. Then you go and do a bunch of inference to generate the images the way you want for your intended application, right? So that means that's why we are supporting fine tuning today in the service. We are in private preview for stable diffusion, and we're working on other use cases as well. Whether we're going all the way to full training, it's something that, of course, we always consider. We go where the opportunity is, but right now we're very focused on inference and fine tuning.
Right. The world is hungry for AI compute, and there's a perceived shortage of AI compute in the world. But you wrote a really amazing blog post challenging this notion. In fact, what you said was there's plenty of AI compute
Yeah.
available. So I have a two-part question for you.
hmm
One, why is there a discrepancy? Meaning, why do people think there's a shortage? And two, given the current reality, what can developers do to just get access to the necessary AI compute they need to get the work done?
Yeah, great. Thanks for bringing up the blog post. Yeah, I mean the reason I say perceived and it's not, of course, I mean there's definitely a shortage of specific choices of compute. It's a market out there. Price goes up because there's a lot of demand for limited supply, right? So, and also it's very real. Like customers come to us every day that will think that their pain points are availability and cost, right? So let me just start with that. But now, if you think fundamentally and go and think hard about it, the reason that I think this is more of a perceived shortage than an actual real shortage is because of complexity. Really, like, complexity in the following sense. Like, you have a workload, you immediately, let's say you have an AI workload, and immediately assume that you need an A100 to run it. But if you go a bit deeper and you had the right way of actually looking at what the workload actually needs and what the requirements are, you're probably going to find out that chances are that you might be able to live with A10G and then just go and use it. And great, A10G is more readily available, very mature software stack, and can just go ahead and use it. So that's really like a clear one. And we've demonstrated in several of our results, like, hey, this is running on A100s. If you optimize it enough, you might get even similar performance on A10Gs, and now you have a lot more availability. So that means you opened up, because of portability of workloads across different types of hardware, now um, you open up more availability. So that's the first thing. So you might not need the latest and greatest hardware. The second thing is there's plenty of lower end hardware available that if you can make use, great. That's one example that it just gave. But also there's a lot of specialized silicon coming in the market. Like, Amazon has Inferentia, Google has CPU, all of those silicon is becoming more readily available now. If you find a way of using it, then now you open up even more availability of silicon for you to run the applications. Right? That's part of our mission here as well, to simplify the process of making use of this, silicon that's coming up online now. This is public. We work with AWS, and we are adding, private preview of our inferential to offering. It's a great piece of hardware to run a broad class of models efficiently with high performance and reasonable cost, right? So that's why I say that the compute is there,
Yeah.
and it's just that accessing, like getting, making use of it. So maybe we can call this, you know. There is a shortage of the high-end compute readily there for you just to use with business as usual. But if you do a bit more work, you can actually get access to a bunch more silicon. And that's our mission here, to simplify the process of making use of the compute that's already available, right? Unlocking it, let's say.
That's a wonderful point. And that is something that developers should look at, meaning you're building an application and really the compute you need may be well served by something that is not the latest and greatest. You don't even need it. You don't even get close to it. So many people just you make a very good point. Like, just take a second look and know that, does your application really, I mean, really, does it need the absolute latest GPU from NVIDIA? The answer
Hmm.
is, in most cases, most applications are kind of simple. So no is the
Yeah.
answer. That's
Or even for
wonderful.
the complex ones, right? Having the
Yeah.
right, that's why it goes back to the self-optimizing, so choosing the instance automatically. Our goal here is, human creativity and human cognitive cycles are limited. We want human brains to focus on building, imagining what are the awesome things we want to build for people. All this other stuff is actually automatable by computers, and that's our mission here, is to have people not have to worry about, do I need the latest and greatest? No, we just want the thing to run. Give it to us, we're going to run it for you, right? So.
Right, right. Perfect. Let's say I'm a large company and
Mhm.
let's say I'm in charge of all the data and AI related work that happens. And I just realized that, hey, many teammates are running all these AI models. So maybe I should have an internal inference infrastructure. I need to set it up. I don't have it. I need to set it up. And
Mhm.
and I'm open. I'm open to buying GPUs, renting GPUs, going serverless GPU offering from somebody. So if you're advising me in this situation to
Mhm.
set up this inference infra for my very large company, what would you tell them? Like, how should they think about doing something like this?
Well, you're talking about how should they think about doing provisioning for what they need?
Yeah,
Is that
like
what you're
I want to
saying?
enable my 100, 200, 300 people who are
Mhm.
running these internal AI models. I want to provide some infrastructure for them so that they don't do like 300 different things. So again, if I had
Yeah.
to, yeah, yeah, that's
No, got it. Yeah. So I think the very first thing is understanding the compute requirements for the intended application, right? So these hundred so people, and what are they doing with it? What kind of models are they using, and how much compute do these models use, and how much usage do they expect on these models? They can start dimensioning how much compute capacity they need, right? And then if you're going to go private deployment, you're probably going to be at the risk of over provisioning and paying your costs for it, right? So you have to choose what kind of overhead and costs you're going to have. If you want to have the independence and have it on-prem, then have to go and do a very significant over provisioning to be able to sustain peak load, or are you willing to, use a cloud provider and a compute service provider that, of course, everyone needs to make money, there are margins involved, but then you have the benefit of elasticity and the benefit of not having to worry about managing your own infrastructure, right? So I think that the key thing there is just understanding your workload very well, and also be aware that chances are that if there's generative AI involved, these costs are going to be surprising, because as we are just talking about the amount of compute required, like this adds up very quickly. If you're talking about on the order of cents per interaction with a model, and you're talking about thousands of interactions a day, then you're already talking about on the order of tens of dollars, hundreds of dollars a day for this one user, that could, if they're using it quite a bit, right? So in that, this, it's likely to be high. So we are clearly seeing, small companies that spend like large companies in compute just for AI. Like, in fact, it's not uncommon to see some companies spending more on compute costs for their AI needs than they spend on people, which is crazy to think about.
yeah, that is, I mean, the commonly accepted wisdom, your biggest cost is always people, but I think
People,
the AI compute cost is
it's
not
changing
only,
that.
not only is it competing, it is surpassing that
Yeah, and
cost.
this is for companies, of course, that AI is at the center of what they do, right? So,
Yeah, yeah. Your customers and also many people, they must be building all sorts of cool and interesting applications on top of your
Mhm.
platform. Can you share maybe the top 2 to 3 most popular use
Yeah.
cases?
Absolutely. So a clear popular one is using text to image, right? So people are using this for marketing, for storytelling, for forms of human expression, and so on. Like that's a very clear one. Just image generation from text input, and all the variants of that. Like for example, um, you're gonna go and use this for adding a style to images for photos to go and tell a story, involving family photos, or using this to generate characters for kids' stories, or just using this as a way like you have a creative mind and you're able to express visually, right? So that's a very clear one. Another one is, multimodal model interaction, like being able to ask questions over images. Like if you are in retail and you have a product, you're going to ask questions like, what color is this? Does this go well with that? You're going to ask questions about images. These are multimodal interactions with AI models that take both image and text as input, for example. We're seeing folks building, say, document analysis, question answering over documents. That's another clear one. So did I give you like three sort of general templates: text to image and associated ones, multimodal interactions, and then I would say question answering over sets of documents and synthesizing, from a larger body of text, synthesizing, summarizing text. That's another clear one. So
Perfect. In addition to running OctoML, you also have a close association with Madrona as a venture partner. So you
yeah.
also kind of look at companies like younger companies. So if you put on your investor hat for a second, right, and you
Okay.
were to look at, okay, in the world of compute, there's so much work to be done. Obviously, OctoML is doing something, Mosaic ML is doing something else, there's Scale. So what opportunities exist just in terms of like work that needs to be done in the world of compute? What are maybe the top 2 to 3 big areas that you're excited about?
Yeah, I mean, so if are talking about infrastructure space or in general, so or in general AI use cases that involve a lot of computing in general.
uh,
So which ones are
I
you?
mean infrastructure only within AI infrastructure. Yeah.
Oh yeah, no, there's a lot. I'm particularly excited about the middleware aspect of how do you string together, like for this LangChain, and there's Fixie and companies like that are actually creating ways of folks to build with LLMs, and how do you compose them into larger, richer services? How they interact with external data sources? How do they produce outputs that can be you know. I would say, trusted to produce some actions in the like outside their sandbox, right? So I think that's an interesting space. How do you compose foundational models into application components as middleware? The other area I would say that's very rich is just model monitoring, making sure the models are doing the right thing. There's companies like, for example, Y Labs is one interesting one that's doing things in that space. And then giving folks giving builders the ability to experiment and find what model is right for what they want to build is another opportunity, I would say, in the AI infrastructure space. So these are
Yeah.
sort of like
Yeah.
three categories that I'm particularly excited about, because given that's closely in the radar of what we do here at OctoML, that's
Right.
recurring pains that I hear. So that gets me excited about them. I can also
Yeah.
talk about things that I'm excited more in the long term, but I don't know if we're gonna come to
Yeah.
that
Yeah.
later. But
Maybe let's do that. I think that's part B of the question is like in the long
oh,
term, what excites you?
well, there's another side of my intellectual life in molecular biology that I've had now. It's been unfortunately a little bit on pause because OctoML, and I'm very happy that OctoML is using all of my cognitive cycles and then some. But I've done a bunch of research in the past on molecular biology and computing, and I have not done work in the space that we're going to talk about now. But what I'm excited about is the role that generative AI has in life sciences, because if you reflect a bit on what happened with, say, DNA sequencing and DNA synthesis, like our ability to read DNA has revolutionized, the visibility into what's happening in a lot of, live processes, and leads to new ways of thinking about, diagnostics and so on. the ability to write DNA created, for therapies that now we can express in form of DNA or RNA to just go into meaningful gene therapies, right? So, but the problem is that even though AI historically so far has helped understand with all of this DNA sequencing data what's going on, in these complex processes, we didn't quite have a really good story on how do you write new, say, new genes. You're going to write a new protein that can go and do something that has a therapeutic effect, right? So because the language that life has evolved is very, very complex. Okay, I'm going to finish the story in a second. I don't want to bore people here, but now there's a lot of recent results. By recent, I really mean like in the last year and a half or two, on using generative models to design new proteins. Okay, so that they can select on a protein to bind to this specific target, and it goes and generates very viable candidates that people have started validating in the lab and sure it actually does what it's supposed to do. So you no longer have to do design in first principles, which I think would probably have been impossible. But now this actually open up these super meaningful, super viable ways of actually generating new designs, and I think that there's huge benefit to human life involved, and also huge business to be built. Now they have this ability of programming things that are incredibly complex. That the only way to program life, I think, is to use AI, right? So, anyways, this is
Yeah.
like a class of more domain specific models, and I think there'll be a class of companies around using generative AI for life sciences for sure. So,
Amazing. I am also particularly excited about that intersection of
mhm,
generative AI and life sciences. And there's so much work to be done. And especially
for sure.
the amount of computation that biology needs, I think finally we are at a point where we can match the requirements, compute requirements of biology.
Absolutely.
Yeah. Yeah.
And you know what's interesting? Sorry, I hope I'm not getting
No, no,
off track
please.
with your audience here, right? So, but watching these advances also make some goals much more tractable. For example, protein foldings, like proteins, depending on the amino acid sequence, the way they fold determines their function. Okay, so if you go back, say 20 something years ago, when I did some work in that space at IBM Research with the Blue Gene Machine, we're folding proteins by doing molecular dynamics simulation. We're simulating the state of lowest energy and then trying to find the right way. That's just crazy, gigantic amount of computation. It's basically, even with today's computers, it would be really expensive to do. But some of these new AI-based methods made predictions of how they're likely to fold without having to do all the computation required to simulate all the possibilities. And I find it's just absurdly cool results that people have arrived at in the last couple of decades, especially in the last 5 to 10 years now, using AI. Like, I mean, if you look at the Rosetta Fold and the Deep Fold things that Google and the University of Washington too, um, like in David Baker's lab, have shown that you can use AI to make predictions of how proteins would fold. The reason that that's cool is that now you don't have to do all the simulation computation required. It's actually cheaper to use AI than it is to do the full simulation.
Right.
That's really cool to think about. So,
Oh, 100%. That's very exciting. And also I have one last question on this topic
yeah,
before we move
absolutely.
on.
Yeah.
That's funny thing. I think the audience, I might get a message or two from the audience saying that we lingered on this for too long, but I think it's a very interesting topic. Okay. So,
It's worth the risk.
yeah. So if you look at a very young company, let's say it's the company is working on this generative AI and in life
Hmm.
sciences, and many different problems, but because of the nature of the business, it's not easy to like gather quick proof like, hey, we closed like all these customers, we have all this revenue, the tech is working. So it, because of the nature of life science, it takes longer, right? It's more
Right.
fundamental, the research takes longer. So in the very early days, assuming the founder is stellar, like what signals do you look for? Like, do you read the research papers? Do you talk to customers? Like, how do you
Yeah.
know what to bet on?
Yeah. I mean, it's a good question. I mean, if you're so inclined, and it happens to be within the general background. Like, I've invested personally in some companies in this space that I, because not only I like the founder, but I understood some of the science, right? So, um, one of them I'm particularly excited about is A Alpha Bio. For example, they use AI to understand, how things bind to each other, right? Let's simplify it that way. So the signals that I look for is, assuming that let's say understanding the science more deeply is just out of the question, is partnerships and connections to bigger players in the space. Like there's a big pharma company that's interested in a partnership because of the expertise and because of the solution they're working towards. Those are good signals to look for. That's ahead of the home run of actually affecting some super high value therapeutics target or and so on. But I mean, just the partnerships is a signal that I look for. So.
That's actually pretty interesting. I think that's very
Because those happens
signals.
very early. Those tend to happen early because they're
Yeah,
based
yeah,
on,
yeah.
a company seeing, bigger players in the space seeing that there's an opportunity for this to solve a problem for them, right?
Yeah,
So,
yeah, that's really fantastic. I think apart from doing the simple basic homework, like hey, the founder is good, they know what they're doing. I think this is a very good signal because
hmm
big pharma companies they don't do stuff unless it maps to a big revenue engine or something. Like it has to connect to something big, or else it's just not worth doing. I think that's a signal that hey, okay, if they're paying attention, maybe it means something to them. So
right.
worth paying attention to
Yeah.
the company. Cool. All right. If you look at the, and you talked about how for each for each image generation or to generate a token, there's so much computation involved,
hmm
and many people are working on making context windows larger and larger for
That increases
LLMs,
the
right?
compute requirements.
Yeah,
Yeah.
yeah, exactly. So can you explain actually two things then? One, it, the size of context window, will there be a point where the incremental benefit will flatten out? And two, how does the increase rate of increase of the window size, how does that relate to the rate of increase in efficiency we are achieving, or are we just spending more money to make the context windows bigger and bigger?
Yeah, it's a great question, and now it's touching on research that some of it is fresh, and it's not that I'm a super deep expert specifically on LLM. So a lot of it, I remember that I'm more on the systems
Yeah,
side, but
yeah.
of course I'm curious, and I support applications like that. So I'm going to tell you as let's say a reasonably informed person in the space, right? So, first of all, longer contexts allow you to capture more correlations with a larger piece of information. That's like the basic intuition there, right? So, there is clear indication that there's diminishing returns there. Like, for example, there was a result from Percy Liang and others, and I don't know if you saw a few weeks ago that showed that for large contexts, if you put a piece of information there and you ask questions about it, and you get very levels of accuracy where it's high in the beginning of the context and it's high at the end of the context, but it's low in the middle, right?
Right.
It's That's super interesting. But now people found that experimentally. It's not that people understood. It's not that you had computer machine learning theoreticians and computer scientists that and understood the algorithm deeply. This is all observational, and a lot of this and this is the case with a lot of LLMs research right now. That people observe this experimentally and then they adjust it, right? So my gut intuition from reading a bunch in this space right now is that I think there's clearly diminishing returns. I think past a certain point, it probably doesn't make sense to extend the context further, which is good news because the longer the context, the more baseline computation you're going to have in every single token that you generate because you have to go and compute the effect of that context in every single output token, right? So now there are ways to get around it with more complex systems, right? So you can chop up your pieces of information, you can information into pieces and put them in vector databases and then retrieve them and insert in the context as needed, right? So I mean, there are ways to get around it. So I don't know if I answer your question directly. I give a lot of how I'm thinking about it, but
Yeah,
we support models with longer context. They have shown utility in several cases, but
yeah.
now very long context. You're talking about millions. Then I question whether it's actually going to be useful. So
Yeah. No, I mean, we can talk about this all day long, but we are at the rapid fire round. So
okay,
I will,
right?
I will ask a series of questions and would love
Okay,
to hear your answers in 15 seconds or less. You ready?
okay, yeah.
All right. Question number one. What's your favorite book?
Okay, there's so many. So one nonfiction is Thinking Fast and Slow by Daniel Kahneman. It's about efficient intelligence. But I can't resist sharing a fiction one, which is José Saramago. Blindness is a great one.
Amazing. Yeah, I love Daniel Kahneman, the author. It's a fantastic book. All right. Next question. What's your biggest AI prediction for 2023?
Wow. Okay, so 15 seconds or less, I'd say that the majority of applications written this year are going to have a meaningful AI based component. The majority of the applications, though.
Amazing. Next question. Looking back on the last 12 months at
Mhm.
OctoML, what's the best thing you did to position yourself for success, future success?
Focus. Focus.
Perfect. All right. Next question. According to you, what separates good AI
Mhm.
products from the great ones?
Oh wow! I think it's user experiences. I think the great ones are where the AI component kind of disappears and becomes natural. You don't think about it. I feel like those are the ones that separates the good ones from the great ones. They're all good because they all do amazing things, but the great ones are the ones that are doing the amazing things, and you don't have to think about it. So
Oh, I love that. It's funny thing how as the product becomes better and better, customers should feel less like AI should kind of disappear in the background. It should
disappears.
become
That's
just
right.
yeah. It's amazing. Next question: as a founder, what have you changed your mind on recently?
Oh my God, that's so many things. You got me on that one. So I should have thought ahead. So I would say that there's so many things, but I firmly believe that it's much more important doing the right thing than being right. So I changed my mind a lot. So this is why there's so many things. I don't know if I can pick one.
Sounds good. Next question: what's your favorite question to ask when you interview like ML developers?
Yeah. Oh, ML developers in general, or
Yeah, just like when you
uh,
conduct like job interviews, for example.
yeah, I try to ask questions that shows how fast they can learn, and also understand overall creativity and ability to interact with others. Because normally when you get to an interview with me, normally because the bar is ready, it's very pre-filtered quite a bit. I have the privilege of talking to folks when there was quite a bit of pre-filtering, so I tend to focus on creativity, ability to learn fast, and questions that touch on, are they going to be good team members, right? So because in this space it's hard to do anything alone. You have to do it as part of a team, and then having good team fit is really important. So
That's actually really good. I'm going to sneak in a part B to this question because
yeah.
you made a very interesting point. How do you test a technical person? Because it's a fairly technical role. How do you test them for creativity? Or rather, what tells you that this person can do some creative thinking?
Yeah, I try to, do a little bit of, try to understand what are the edges of what they consider to be like their core expertise, and ask questions right at that boundary and pushing a little bit outside to see how they're thinking creatively outside. Not because I'm trying to like, oh, are they going to be right or something? I don't know. It's mainly to see that does it look like they are expressing creativity, offering various solutions, and also importantly, exposing how they're thinking. Often maybe it's the educator in me. Like maybe I can't do, I've been a professor for a long time before, starting OctoML. So I've always liked, seeing how people think than seeing the answer. So like asking questions that shows how they are thinking is easier to judge creativity than just thinking about, an answer that and then think about the answer directly, right? So
Right. Right. Final question. What's your number one advice to early stage founders?
oh wow, pick a really good team. Like do everything you can to build the very best team you can, and work on making that team as productive as they can. Because once you if you make the team successful, you're gonna make the company invariably gonna make the company successful. So thinking about being the best team possible and what is everything that you can do to make that team successful is number one advice that I have. So
This has been such a brilliant episode, Luis. We covered so many topics, and again, I'm always
you're
amazed by
talented. You know how
yeah.
to.
No, I think the you have such in depth knowledge about this. I mean, it shows like you've spent your life in this, and it just the richness of your knowledge is just fantastic. And I always love when that happens. So thank you for bearing with the questions and diving deep into some of these topics.
No, thank you very much, Patrick. It's been a pleasure. So hope to stay in touch.